In this video, I'm going to walk through the calculations for part B of the constant pressure calorimetry experiment. Okay, I've already kind of prepped my board a little bit with a few things, but where we can start to look is let's talk about what happened in the experiment. So up here in this left-hand corner. So you had your calorimeter, your calorimeter, which was AKA your styrofoam cup, with about 50 milliliters of water in it, and then you added some amount of salt, roughly 2 grams of solid salt into your calorimeter, and you stirred. And you waited to see what happened to the temperature of the water. Right, so you took an initial temperature water reading, then you added salt, and either you saw the temperature increased or decreased. And given the salts that, the 2 salts that we're using, in one example, it should increase, in the other example, it should decrease, because it's just showing that dissolving salts can either be an endothermic or exothermic process. Remember, endothermic is absorbing heat, so if dissolving the salt had to absorb heat, that means that you should see the temperature of the water decrease, all right? Because the salt is stealing heat from the water molecules, essentially slowing them down a little bit. Okay. If the salt dissolving was an exothermic process, so if that released heat into the system, then you would see the temperature of the water increase. Okay. And remember from first video, which gave a really extensive background of Q and whatnot. Please watch it if you haven't. The Q of the salt, so remember Q is the chemistry variable for heat. So the heat from the salt has to equal the heat from the water. One of these is absorbing and one is gaining. So one of these will be negative and one of these will be positive. And it just depends on whether or not dissolving the salt was endothermic or exothermic. If it's an exothermic process, it'll be negative. If it's an endothermic process, it would be positive. And normally you can see that value from the delta T, okay? Because remember the Q equation, so heat is equal to specific heat capacity times mass times change in temperature, okay? The enthalpy of the salt, which is what you're asked to calculate, is equal to the amount of heat produced by the salt, either released or absorbed, but the heat from the salt, dissolving the salt, divided by the total number of moles of salt. Okay? So in order to find the heat from the salt, remember, you didn't directly measure the heat from the salt, but you did indirectly measure it because you watched what happened to the water. Okay? So in one experiment, I don't know which is which, I apologize, but let's use magnesium sulfate for one example. So magnesium sulfate, I'm fairly sure that's an exothermic salt dissolving reaction, because when you put it in water, it gets hot to the touch. So it's releasing a bunch of heat, okay? So if I had about 2 grams, so get rid of X, if I had about 2 grams of magnesium sulfate and dissolved it in the solution, I saw the temperature of the water increase. So I can, using this relationship, figure out how much energy how much heat that the dissolving of the salt released by looking at the water, right? So Q for the water, we know the specific heat capacity of water is 1 calorie per gram degree Celsius. We know that the mass of the water, we had 50 milliliters, and the density of water is 1 gram per milliliter. So every 1 gram weighs every 1 milliliter weighs 1 gram. So you had 50 grams. And then you have your delta T. And so whatever your change in temperature was, and change in temperature is always final minus initial. Okay. And once you have those values, so you have your 1, the 50, and the delta T, you figure out what the numerical amount of heat was that the water absorbed. Okay. Then using this relationship, right, it's just the opposite sign. It's the same amount of heat for the dissolving salt process, but just the opposite sign, okay? So that's how we figure out this numerator value here. Now, how do we figure out the moles of salt that you dissolved? Well, this is a little more intuitive than the part A, because if you have 2 grams of salt, you essentially have to figure out how many moles that is. And the way to relate grams of a compound to moles of that compound is through its molecular weight, right? Because molecular weight has units of grams per mole. So you can set up a quick dimensional analysis table and say 2 grams, and whatever the molecular weight is in grams for every 1 mole, and grams would cancel and you'd be left with moles. Okay, so you need to calculate whatever the molecular weights are, and then make sure you're keeping in mind significant figures for the value that you weighed out. And that's how you get your denominator here, this value, and then you just take your numerator and divide it by the denominator, and that gives you the enthalpy of the dissolution process for that salt. If you have additional questions, remember you can post them on the discussion board.